So our broadcast facilities have always used purpose-built hardware, such as audio consoles and turntables and CD players and hardware devices like traditional audio processors or even STL equipment. The simple fact of using this purpose-built equipment pretty much requires that that equipment be physically at our broadcast facility, inside a brick and mortar building. We can call this as being, of course, on premises. As we look to convert some or all of our broadcasting infrastructure to virtual or containerized software systems, we'll typically think of having these new virtual systems on premises. After all, we already own or lease the building space, and we're just upgrading the broadcast functionality that we already have. However, if we're starting with a clean slate, if we're downsizing our building requirements, or we'd like to have backup or disaster recovery infrastructure, then we want to consider off-site broadcast infrastructure. So when going off-site, we'll be considering the services of a private data center or one of the public cloud computing platforms like Amazon Web, Microsoft Azure, or Google Cloud. Let's take a minute to get on board with definitions now and examples of each scenario. On-premises. Well, on-premises means installed and operated in-house. It means customer-owned servers and computing infrastructure. It means the customer, you, me, those running our radio stations and engineering for them, we're responsible for things like computer security, the uptime or availability of these systems, managing them, and maintenance of them. And note that software vendors may provide integration and support services, and this may be very needed as we're on kind of a leading edge for these technologies, at least in the broadcast world. So what does on-premises container deployment look like? Well, for most broadcasters, it simply means adding a server computer or two to the existing rack room. Then within that server, we're going to install one or more software containers to provide the additional broadcast system functionality. Now, with extra software audio consoles, we can provide convenient and on-demand mixing and on-air phones and other services. Here are some examples of what we can do. We can add or replace audio consoles. Again, we can do on-air phone systems in a container. Sports and holiday programming, we can run those. Maybe you have some special election coverage. Maybe you want to add some HD channels and occasionally run those live or do some mixing there. Or you have some paid programming that you want to put on the air. So this is what that would look like in your existing facility. Also on the screen, I've shown a remote home user, since that still can be a thing. Now, what about perhaps putting your containerization into a private data center? What are we talking about here? Let's define that. In a private data center, you own a secure space in a secure building. You get clean power and a clean operating environment. These tend to be customizable for your operation. I will point out that private data centers will vary a lot. There's some standard things that you get, and other things are variables to what one private data center will offer versus another. But typically, it's customizable for what you need. There would be no sharing of resources in the data center except for power and internet and HVAC. Of course, you're going to get very fast and hopefully redundant internet access with a data center. After all, it is a data center, and it's their job to provide that. Interestingly, in a private data center, you might be able to install non-server gear in there. That means that if you need to, for example, place an Omnia 9 or an Omnia 11 processor at the data center, well, at many data centers, you could do that. As long as it fits in a rack and does what you need, you could do that. And as I mentioned before, you probably will have backup AC power, something that you may not have or may not have as reliably as you think you have at your studio, unless you do regular generator maintenance and backup battery systems. So a data center specializes in those things, and they're going to have them. So broadcasters may choose to locate some of their infrastructure in that private data center. The physical security and environmental stability are usually better than a broadcaster can provide in his own studio facility. And internet access in a private data center, again, should be blazingly fast and redundant. Because the broadcaster will have his own caged area with equipment racks, it's often permissible to install other professional gear in addition to any servers that you put in there. A broadcaster could install hardware audio codecs or audio processors, for example, if they weren't ready to virtualize every piece of broadcast gear just yet. There's still the capital costs. The servers and other equipment are your responsibility to purchase and install. This practice varies, again, from one data center to another. What are some more example uses here? Well, pretty much like the other list, sports and holiday programming, election programming, some extra HD channels, maybe paid programming, but let's add one to the list. Let's add disaster recovery to this list of things that you could reasonably do in a private data center. After all, it is separate physically from your studio facility. Now let's look at public cloud, like Amazon, Microsoft, and Google. What you get with public cloud is you get compute space on the provider's servers. You rent exactly the compute resources that you need. You get a secure, of course, and an environmentally controlled location, but you only get servers. You can't stick your broadcast gear there. You have to be able to do this on server platforms. Of course, you get fast and redundant internet access, typically, right at the backbones, and typically several of them. You'll get backup AC power, and typically these places are disaster hardened. In fact, a lot of times they put them in places that are not prone to severe weather, or even not prone to earthquakes, for example. Now, not every Amazon, Microsoft, and Google data center can be located thusly, but they really do try to make these places hardened. And again, there's no customer physical access to these. You are remotely gaining access to compute space. All right. So here's why they may be ideal for hosting our broadcasting infrastructure. These services are renowned for their reliability and their super redundant connectivity with the public internet. Geographic and even green energy options, if that's interesting to you, are available. Note that a broadcaster, again, would never install his own server or other equipment in public cloud data center. We only rent compute space. These are highly sophisticated. They're well-planned virtual servers. The whole setup is designed by, frankly, computer scientists and managed by a fleet of tech professionals. Uptime is everything to these folks, or we should say apparent uptime, because you may be slipped over to another machine without hardly realizing it. Systems do fail, but they have automatic virtual failover. It's kind of a normal feature of today's cloud computing services, and users, again, would often be unaware of changes or failures. Note that customers have no physical access to these public cloud data centers. All work has to be done remotely through secure connections. For broadcast functions, doing things like moving recorded audio files up and down, voice tracks, new music, whole program segments, these are easily transferred in and out of our software containers. No problem. Live audio is possible too. I say that slowly and carefully because there typically are data charges for ingress and egress. And if you're doing live audio, well, you probably want to use compressed audio if you can. But if you do use linear audio, just be aware that the meter is ticking on the data that's passing in and out of a data center. Yeah, it's very, very cheap per megabyte, but eventually they do add up. We can also get live processed audio in and out or out of the cloud and to our transmitter sites or other destinations. We'll look at an example of that in a few minutes. Some example uses, well, pretty much same as the private data center, sports and holiday programming, additional capacity, elections, HD channels, paid programming, and also disaster recovery. Very appropriate thing to do with a public cloud infrastructure.